want the volume, right? Because when you graph that on the calculator, you get something like this. I'm going to just exaggerate it so it looks... So this is x cubed plus y cubed equals 8. Okay. So basically the area is this, right? And we said we can easily get those intercepts. Because if y is 0, this is 2, and if x is 0, this is 2. And you can write out f of x equals 8 minus x cubed 1/3. Look how I would have done this. I would have taken a slice here. We're rotating about the y-axis. So the question is, what's the volume of that you get when you spin this area around the y-axis? So the way I would have done it is, I would have taken a slice here. Let's say this slice. Yeah. Okay. And you could spin this about the y-axis. And when you do that, you're going to get a shell. This is called the cylindrical shell method.
Yeah,
right? Okay, and we know what the volume of this shell is.
right.
So the V, and then you could, so the V of this one shell is this is a dx here, right? So this will be 2 pi 2 pi times the height, 2 pi r h times the thickness, which is dx. So this is for one of them, for one shell. And if you integrate this over the entire area, going from 0 to 2, you would get the V for your surface. Now the question becomes, what's R and what's H? Well, let's go to here. This is your R, to the strip. So this is your R. And H is just the height of the strip. So, right, the Y for the graph, which is 8 minus x cubed to the 1/3, and R is just, what do you think R is? R is x?
R is x, yeah.
Because the distance from there to. So then V would equal 0 to 2 pi x 8 minus x cubed to the 1/3. And this integral, we can rewrite it as a beta function. Yeah. So we could factor out the 8 to the 1/3 times x. Times x. 1 minus x cubed over 8 to the 2/3, to the 1/3. And then we can call this t here. You follow?
Yes.
So t is equal to x cubed over 8, which makes x to be 2t to the 1/3, which makes dx 2 over 3 t to the minus 2/3 dt. And now plug it in. So v becomes 2 pi. Now let's switch the bounds. If x is 0, you get t to be 0. And if x is 2, you get t to be 1. So this becomes the integral from 0 to 1, 8 to the 1/3. I can 8 to the 1/3 is just a 2, so this becomes 2 squared. Yeah, x is 2, so bring the 2 out. T to the 1/3, 1 minus t to the 1/3, and dx is 2/3, so another 2 here over 3, t to the minus 2/3 dt. And so this becomes 16 pi over 3. You agree? 4 times 4, 16. Combine these two here. You would get t to the minus 1/3, 1 minus t to the 1/3 dt. And the reason we did this is to compare it to this guy here. Because b pq is equal, this is the beta function, the integral from 0 to 1, x, or let's use t, since this is t to the p minus 1, 1 minus x to the q minus 1 dx. This is the beta function, and now just match them. So this guy has to equal this guy, and this guy has to equal this guy. So p minus 1 equal minus 1/3, so p is 2/3, and q minus 1 is equal to, oops, wait, this is, yeah, minus 1/3 one is equal to 1/3, so q is equal to 4/3. So that means v is just, right? V is just 16 pi over 3 b of 2/3, 4/3. And this, according to the, so now I can invoke here the gamma function. So this becomes gamma of 2/3 times gamma of 4/3 over gamma of 2/3 plus 4/3, which is gamma of 2. Gamma of 2 is gamma of 1 plus 1, which is 1 gamma of 1, and gamma of 1 is 1 by the definition of the gamma function, right? Gamma of 4/3 is equal to gamma of 1 plus 1/3, which by the recursion formula is 1/3 gamma of 1/3. So far, so good. So now if you plug this stuff into V, you will get V equals 16 pi over 3, gamma of 2/3, gamma of 4/3 is 1/3, gamma of 1/3. And gamma of 2 is just 1, we said. Okay, so how do you manipulate gamma 2/3, gamma 1/3? Let's see if we could manipulate these using 1 minus 1/3 is 2/3. Yeah, so gamma of 1/3, gamma of 2/3, because look, gamma of p, gamma of p minus 1 is equal to pi over sine p pi. So this is 1 minus 1/3. So according to that, oops, wait, it needs to be p minus 1. No, it doesn't work. We'd have to leave it. What answer did you get?
I got 32 pi.
No, that's the final answer after everything?
32 pi 3 halves over times x root.
Oh, wait. That's not the complete volume, is it?
No.
Complete volume. There we go. Let's see how. So we need to manipulate gamma of 1/3, gamma of 2/3. Yeah. Gamma. Oh yeah, that's why it didn't work out. I have those swapped. This is 1 minus p. Yeah. Okay, so it does work out. So when this is 1/3, yeah, times 1 minus 1/3. This here is the 2/3, 1. So according to that formula, this is pi over, so in this case, p is 1/3 here, yeah. So pi over sine pi over 3. So this becomes 2 pi over root 3. Plug that in V. So this way you only need to do the integral once. So you get 16 pi over 3 and gamma 1/3 times gamma 2/3 turned out to be 2 pi over root 3. Yeah, and you have 1/3. Root 3 over 2. Yeah. So now you could multiply here by root 3. So that's to get p, and the final answer will be equals 16 pi. What do we have here? We have times 9 is 27, and we have 32 pi squared times root 3. This is V. I think this is better than the first way because you only evaluate the answer once. You get what I'm saying?
I guess.
How I set up the volume.
Yes, yeah. How come you got 27?
Not the complete volume. Is the complete volume?
I guess well, I got this.
No, but this wasn't. Wait. This wasn't that. This was just the xf of x dx. You still had to evaluate the area. Divide.
Right,
This is
that's
much
X.
longer than that.
Oh,
This way you could shortcut it by using the. This is called cylindrical shell method.
yeah, that's what I thought we were going to do in the first place.
This is called cylindrical shell method. To find V, the rotated area, volume of the rotated area.
Right. All right. Okay.
Okay,
Yeah.
you understand the setup?
Yeah, I get
Okay, should we continue next time?